Okay, random number generators. Random method generates a floating point value from zero point 0.0 up to but not including 1.0. So it could be 0.99999 and so forth, but just short of 1.0. Random integers in certain range can be generated by scaling and shifting the values returned by the random number generator, then using math.floor to convert them to integers. The scaling factor determines the size of the range, i.e. scaling a factor of 4 means 4 possible integers. The shift number is added to the result to determine where the random begins. So shifting the numbers by 3 would give numbers between 3 and 7. We'll see some examples of this in a moment. Method math.floor rounds its argument down to the closest integer, so it's a round down method. We have an example here that's going to show you, so it's going to be, the way the random number generator works is it's not truly random, but it's close enough. It works off of the clock ticks, the millisecond clock tick on your computer. And a millisecond is 1/1000th of a second, so it's really fast. And it would be almost impossible to predict what that number is, because every computer is different, doing different things, got different jobs going on, memory usage, and that actually slows the clock or changes the speed of the clock either faster or slower ever so slightly. And when you're down to a millisecond or a 1/1000th of a second precision, it basically makes it virtually random. I mean, almost impossible to calculate it. It's so random that almost all games, period, use random number generators when the computer plays you, and including gambling games where money's at stake. The online games, the machines, that games that you go to in the casinos and stuff like that. They all use this random number generator to figure out what card to pull out of a deck, for example. In this example, we're just going to put random numbers between 1 and 6. So remember that the highest number is 0.99999. So if you want it to start with 1, it has to be a 1 there, plus whatever that thing generates times 6. So 0.9999 times 6 would be 5.9 whatever, something or other. And remember that floor rounds it down. So it would round that 5.9 down to 5, so adding 1 to it gets it back up to 6, which is where you wanted your range to be, okay? So that's kind of how that works. And it'll show you that it's going to generate random numbers every time. Different set of random numbers every time. We can go ahead and take a look at this, and we will see that it will be random numbers every time. That. Random numbers, and every time you refresh it, you're going to get different numbers. As you can see, every time you run it, we're getting different random numbers. And these could be cards out of a deck to play poker or whatever. Next example shows you how to pull random images. And I don't know that I've got this one working or not, but we can look at what there it says. It basically works the same way. It's just randomly pulling a image out. So it's basically going to roll die, but I think this is using a dice of some kind. We'll worry about this stuff later on, but it gets a handle to that. We haven't really gone into the document object model yet, I don't think. So document.getElement.byID. Remember we added IDs in lab 1? That ID will allow you to basically get a reference or a handle, what we pull to that tag, and then allow you to manipulate it in some way. In this particular case, we're setting those. And then it's got a loop that pulls a number between 1 and 6, and the dice have a value somewhere and it's setting it up so it's randomly pulling a number and adding that onto the die. So, die 1, die 2, die 3, and so forth. And the for loop does that. It's a function actually. It just cuts it. So that every time you load, you're essentially going to get a different dice. Just like we got different numbers every time I loaded it. And I don't know that I've got this one. Let's see. But it's the same concept of the example we just did. Okay, so this is different. This is giving us a frequency. Okay. But it's the same concept. That it randomly picks dice. There's other things you can do. We looked at random images. Until now, the user interaction with the script had been through a prompt or alert box. These dialogues are valid ways to receive input from a user and to display messages, but they're fairly limited in their capabilities. A prompt dialogue can contain only one value at a time from the user, so it's been pretty primitive. Inputs are typically received from the user via an HTML5 form, which we actually did work in Lab 1 on an HTML5 form. We haven't done much since. I think we talked a little bit about event handling, and we're going to get into a little bit more pretty soon. JavaScript is generally used for handling events, responding to events. There's some intelligence to it. Scripts are often used to respond to user-initiated events. We already know what the body element is. This is used exclusively for all the elements within the main part of the document. The form element is where you would put all kinds of input boxes and drop-down lists and radio buttons and check boxes and so forth. The string pound is used to simply allow the document to validate itself instead of actually submitting somewhere. So pound by itself represents the current page. Button input element and event-driven programming. So event-driven programming, and again, we looked at a little bit of this already, but event-driven programming, the user interacts with an element in the web page. The script is notified of the event, and the script processes the event. The user's interaction with the GUI drives the program. The button is known as the event. The click event is actually more specific. And the function that's called when the event occurs is known as the event handler. When a GUI event occurs in a form, the browser calls a specified event handling function. Before any event can be processed, each element must know which event handling function will be called when a particular event occurs. So we'll see some examples of this in a moment. IMG elements will display 4 random selected dice. We saw that earlier. And you can also use them to apply CSS styles, enable script code to refer to these elements in the HTML5 document. Because the ID attribute, if specified, must have a unique value among all ID attributes on the page, JavaScript can reliably refer to a single element via its ID attribute. So that's how we get a hold of a tag on a web page. Each IMG element displays the image blank.png, an empty white image, when the page first renders. Specifying a function to call when the browser finishes loading a document. Many examples, and we'll see some examples of this as well. Many examples will execute a JavaScript function when the document finishes loading. This is accompanied by handling the Windows object's load event. To specify the function to call when the object occurs, you're registering an event handler for the event. Method add event listener is available for every DOM node. The method takes 3 arguments, and it's actually a simpler way of doing this. I hope they didn't show the hard way. The first is the name of the event for which we're registering a handler. The second is the function that will be called to handle the event. The last argument is typically false, true values beyond the book's scope. To show the random values representing the dice occurred with approximately equal likelihood, let's allow the user to roll 12 die at a time and keep statistics showing the number of times each face occurs. Okay. Got these frequencies. Start. Let me see if I'm doing it that way. Okay, so they're doing it a little differently than me. Function start. Function roll die. Oops, not that one. Tally rolls. So, interesting, they're doing a roll button, which you don't really need to do. They're using this button.add_listener, which is okay, but you can also just let's see here. Nice tally rolls. In my case, I was doing it 6,000 times. They're doing it just 12 times. Doing it in two different methods. So one of the things they're doing is they're getting the die number. Okay, I don't have the image, so I'm doing it without the image. This is their update. I could do it that way as well. I I think I had it all out as one big function. So they're doing this add listener, which is the start function on load. That's one way of doing it, but you could also do, I think it's body on load equals, I don't think we really have a start. Here in their form, the action is the pound sign. I think somewhere in here they also do the button and they add the listener. You could do that. You could also just on the button say on click equals roll die. Could just do that too. I'm not sure why they're doing it that way. It's easier to do it this way. It's sort of an older way of doing it too, as far as I know. Alright. Body missing the close tag. Good. Ooh, there you go. That's why we're getting some weird stuff in there. Thank you there. Give me a button. Can't do very much. What happened? Button. We don't have the this should have been value. So we had some errors, which is why I took Firefox. Console. Balance tree. Roll die is not defined. So it's saying that roll die is not defined. On click roll dice. It's a lowercase r. And then we wound up with another. Or it just didn't do anything. I think I know what the problem with that one is. Yeah, that's what I thought. Okay, that actually I think should work. I hope. Get element by ID, enter HTML equals die table. When does that work? Take element by ID, or HTML. Okay, something weird's going on. It's not calling it button roll die. On click equals roll die. Oh, it probably does call the roll die, but it doesn't call update document. Let's do this. Update doc. Okay. Hey, there it is. That worked. Get rid of that. So it's doing it a little differently. It's not resetting the value. What's happening? Okay, I know that one was pretty long. Any questions on that one?